In this video, we are going to discuss about the application of first law of thermodynamics. The first law of thermodynamics has been successfully applied to a number of physical and chemical processes. So here we'll see what is the application of first law of thermodynamics in case of heat capacity of gas. Now from the first law of thermodynamics, we can write the differential form of the first law of thermodynamics as del Q equal to du plus del W. Now del W can be written as P dV, which is the work done. Du is the change in the internal energy and del Q is the heat imparted to the system. So del Q equal to du plus P dV. So this is the first law of thermodynamics. Now since U is the function of state, we can write U as a function of volume and temperature. So you can see we have written U as a function of U, T and V. Now applying the partial differentiation, we can write the change in the internal energy as del U del T V dt plus del U del V T dV. Now we put the value of du in the first law of thermodynamics. Therefore we get del Q as putting the value of du here, del U del T V dt plus del U del V T del v, dV plus P dV. Now we have written here del Q taking this dV out, so del U del V T plus P. So we are marking this as equation 1a. Now at constant volume is not changing, that is we are talking about the isochoric process. So in isochoric process, dV equal to 0 since the volume is constant, so this part becomes 0. So we are left with del Q by T. So if we take the change of the heat with respect to temperature, so at constant volume, this del Q del T V, this is basically the heat capacity at constant volume, which is given as del U del T V. So what is CV? As we know from our previous knowledge that CV is the heat capacity at constant volume, and we are taking this for 1 mole of gas, which is also known as the molar specific heat at constant volume. So this we know that this is the heat. This is the heat required for the system to increase the unit temperature of the system by keeping the volume constant. Now this is from our previous knowledge. So what we get that from the first law of thermodynamics, CV is also the change in the internal energy for unit change of temperature with respect to volume. So CV becomes del U del T at constant volume V. So what is CP? CP is del Q del T P. So CP is the heat capacity at constant pressure. Now from this equation, that is equation 1a, we can differentiate del Q with respect to temperature at constant pressure P. We can get Cp equal to del Q del T P. So if we differentiate it with respect to temperature keeping the pressure constant, we get this equation del U del T V plus this thing inside the bracket and del V del T P. So del U del T V is again CV from equation number 2. So Cp minus CV is del U del V T plus P multiplied by del V del T at constant pressure P. So this is the general form of the difference of the heat capacity at constant pressure and at constant volume. So Cp minus Cv is given by this equation. Now from this equation, utilizing this equation, that is a general form of the difference of heat capacity, will apply it to the ideal gas and also the real gas.